Welcome to a short tutorial on miter plates with SolidSteel Parametric for Autodesk Inventor. The video is a supplement to the manual that you can open by clicking the Help button in the tool dialog. We start with this simple sketch and quickly place two profiles. Please note that there is also a detailed tutorial video on how to place profiles on our channel. Here is our starting point, which could be the ridge area of a hall frame, for example. The miter plate that we are going to use for the connection is a special type of end plate. To differentiate between the two types of end plates, with the normal end plate connection, we are connecting a source beam to a target surface. But that doesn't make sense here, because then the end plate would be inserted in the orientation of the target face. In addition to the unusual appearance, this would also result in an unwanted offset. Instead, we want to insert the plates at the bisector of the two profiles to get a clean detail at this point. This is exactly what the miter plate feature is for, which we can find in the drop-down menu under End Plates. You can see the difference to the end plate right here at the top of the selection, because two beams are used as input instead of one beam and one face. We select the two beams and immediately see a preview in which we can also see that the angle bisector between the beams has been determined automatically. As usual in SolidSteel Parametric, we can set everything, which means that we could also force any angle here. However, as you can see, this makes no sense for symmetrically angled beams, but can be quite useful for asymmetrically inclined roof halves, for example. I deactivate the force angle option again. A double plate is a good choice at this point. I activate the option and the preview is adjusted again. At the same time, the already checked option plates are identical appears. If we unchecked it, we would be able to define both plates individually. We re-enable this option, which is the default in this installation situation. If we want, we can define a gap, for example as a welding gap, but I leave the value at 0 here as well. As with the normal end plates, we can also select from the standard templates for the miter plates that match the profile size. This means that all the entries have already been made in the dialog, and we have a good starting point for our own adjustments. We have our offsets. We have a material thickness which seems a bit large to me. I change it to just 30 mm and we have a hole diameter, which is also quite large. No problem, a click on Assemble opens the part selection, in which we can define the desired bolted connection and thus automatically specify the hole diameter. Here on the left we can select the screw standard and the diameter. M27 is suitable for such a connection. Here on the right we see the tabular list and the schematic drawing of the entire bolted connection, including washers, nuts, and the grip length. The grip length can be recalculated by clicking on Calc Length, but it was already correct. We can confirm and the diameter of the holes will be corrected to the value that matches the bolt. Further down in the dialog, we can select our own plate template, for example plates with rounded corners, and also assign a material. I didn't only mention rows and columns in the whole pattern, but all the options are available here as well, just like with the normal end plates. The main difference with the miter plates is the selection of two beams and the calculation of their angle bisectors. I think the miter plates look good. We can confirm. The connection is inserted and of course two welded assemblies are automatically created. Of course, the miter plate also follows parametric changes, so if we now change the sketch, for example the angle from 160 to 140 degrees, and confirm the sketch with return, we don't see any change at first. As usual in SolidSteel Parametric, the update button must be used to start the parametric update. As a result, we can see that the angle has been adjusted, but the length of the plates has also changed. The plates have become longer due to the more acute angle. Of course, it works the other way around as well. We increase the angle to 170 degrees, confirm the sketch and start the update. As you can see, in addition to the angle adjustment, the length of the panels becomes shorter again, which is logical since the length is calculated based on the cut face. I change the angle back to 140 degrees to show a little more. As you can see, the screws are positioned too high for this angle. To correct this, we will open the miter plate dialog again, switch to the Modified tab, and select our miter plate to make adjustments. In the whole pattern, the top number in rows is the distance to the top edge, and the number below is the distance between the rows of holes. So we increase the top number. 130 mm was too much. At 120 mm the screws should be roughly centered. We can confirm this. Of course, we can delete the miter plate just like any other connection using the delete connection feature, and that brings us to the end of this video. If you are wondering what kind of plates SolidSteel Parametric provides for the other end of the hull frame after the miter plates at the ridge, then take a look at the video on base plates suggested here. Thanks for watching and see you next time.